So you might recall that we had learned that the cosecant function, which is abbreviated CSC, is 1 over the sine function. So you might see that when we're graphing the cosecant function, we are talking about y equals the cosecant of x, or f of x equals the cosecant of x. We have to rely upon the sine to help us get there, okay? So let's take a moment and let's fill in the chart that you see there for what we learned about the sine function. The sine goes 0, 0. Pi over 2, we're up at 1. Pi, we're back at 0. 3 pi over 2, we are at negative 1. And 2 pi, we are at 0 again. So when we learned about the secant function, we learned that there were some vertical asymptotes. Well, our cosecant function looks almost identical, just shifted around a little bit. The cosecant is the reciprocal of whatever the sine value is. So if we have 1 over 0, that is undefined, so that is a vertical asymptote. 1 over 1 is okay, it's just 1. 1 over 0, again, we get a vertical asymptote. 1 over negative 1 is just negative 1 still. And then we get an undefined value again, we get a vertical asymptote. So the secant function had 2 vertical asymptotes within a period. The cosecant function actually has 3. Every place that the sine was 0, we get a vertical asymptote. Every place that the sine is 1, the cosecant is 1. Every place that the sine is negative 1, the cosecant is negative 1. And remember, it's going to bounce off of it and be those parabola-like things that are stuck between our asymptotes. So let's go over here and look at our graph of our sine function. And let's draw it up on the graph paper, and we're going to make it a dashed line. So let's make this 1 and this negative 1. And so it hits 0 at 0. At pi over 2, it is 1, back to 0, negative 1, back to 0. So let's just make that a dashed line. Now let's go ahead and stretch out on our graph paper, because remember, these functions are periodic. They are going to repeat. And so that's what our sine function looks like. Now, when I recommend graphing a cosecant function, my suggestion is always put on your vertical asymptotes first. Our vertical asymptotes are every place that the sine was 0. So the sine graph guides us to that as well. So there's a vertical asymptote here. Now, they are always going to be equally spaced. So expect that they will be equally spaced, okay? Every place that the sine was 1, our cosecant is 1. So let's color those dots in very prominently on our graph. All the upper bumps are going to be a parabola going upward between the asymptotes. All the lower bumps are going to be going downward. If you wanted to think about where things are at for just a little guide, the cosecant of pi over 4 is square root of 2, or 1.4. So that is why this spot's 1.4, this spot's 1.4, and then you get a parabola going up. These spots would be at negative 1.4, and that's just the way our unit circle goes. The top 2 quadrants are positive for the sine, so positive for the cosecant, and the second 2 quadrants are negative for the sine, so they'll also be negative for our cosecant. So we get some graphs that look like that. So if you want to put the 1.4 on, it's fine, but as long as you follow the asymptotes, that's all we really need, okay? So our cosecant function is what we see there in red, and you can see that it is bouncing off of our sine function. So that is what our cosecant function looks like. So you might recall sine and cosine were both waves. They looked alike. Secant and cosecant are both of these asymptote parabola up, asymptote parabola down, asymptote parabola up, and that is the way both secant and cosecant functions look like. Co-functions are always going to look alike, so the next ones we do will be tangent and cotangent, and they are going to look alike, and they're kind of their own unique little animal, okay? So that is the graph of the parent cosecant. Now we have to mess it up. So we might add something to the inside, move it left, we might move it right, that phase shift, we might stretch them. And so that's what we have to practice. How do we mess them up? Well, remember a cosecant function, just like a sine and a cosine and a secant, has a period of 2 pi. We're going to skip any multiples of pi. So this is in the parent function. This is in the y equals the cosecant of x. We would skip pi. There'd be an asymptote. 2 pi, 3 pi, negative 1 pi, 0 pi, 4 pi. They're all going to have asymptotes at it. Now remember, the range has nothing between positive 1 and negative 1. That's where that sine curve is going to live. It's odd like the sine, so we can say that if we stick a negative in the cosecant function, that is the same as a negative on the outside of the cosecant function. So if you were to put into Desmos y equals the cosecant of negative x, and then you were to put into Desmos y equals negative cosecant of x, they're going to get you the exact same thing. The stretch for a sine and a cosine, we call this the amplitude. So you will see that it's not technically an amplitude. Amplitude is a height of a wave. This isn't a wave. So you can call it a stretch. If you call it an amplitude, I'm okay with that. But technically, it is a stretch for all the other functions. So for a secant and a cosecant, a tangent and a cotangent, that amplitude, that number in front, we will call a stretch, okay? But again, if you call it an amplitude, so be it, it's okay. So let's take a look at the function that we see here. So what we're going to do is we're going to make a little chart. Our first one is going to have 3 things in it: x, sine, and cosecant. And then we'll make up an x and y for our new, this will be our new one. So let's just fill in the original, the parent function for these. So at 0, the sine is at 0. At pi over 2, it's at 1. At pi, it's back to 0. At 3 pi over 2, it is at negative 1. And at 2 pi is at 0. So please recall that you need to know that pattern by heart. So remember, our sine goes 0, 1, 0, negative 1, 0. Our cosine goes 1, 0, negative 1, 0, back to 1 again. So you have to know those patterns by heart. Okay, so what does our cosecant do? Because it is the reciprocal of that, we're going to get a vertical asymptote in the first spot, 1 in the second spot, a vertical asymptote here, and then negative 1, and then a vertical asymptote. Now that is if we didn't mess it up, but we did mess it up, so we have to, figure out what has happened. The stretch is going to be 3. The negative is going to flip it over. So normally it has an upper bump, then a lower bump. So the negative just flips it, and the lower bump should come first before the upper bump. So now let's go over all the things we have done in the past. So the period of the function, we're going to set the x term equal to 2 pi. So let's write that down. So you just solve for x, and so now the new period is pi. Anytime you have a number larger than 1 stuck to your x, your period has shrunk. Your waves, if it was a sine or cosine, squished together. In this case, our vertical asymptotes are going to be squished together a little bit more. Okay, let's talk about phase shift. Phase shift is also our starting spot. That is where our parenthesis equals 0. So in this case, our starting or phase shift is 0. This function hasn't moved left or right. It is going to be a vertical asymptote right there at 0. It's going to start with a vertical asymptote. What is our ending spot? Well, our ending spot is where that inside equals 2 pi. And so that's going to be pi. And it should make sense that if it has a period of pi and it starts at 0, it's got to end at pi. So let's put those on there. Now, halfway between 0 and pi is half of a pi, or pi over 2. Remember, for a cosecant, those are the spots for our vertical asymptote. So we don't really have to do any math there. The first, third, and fifth spot of a cosecant is always a vertical asymptote. Now let's break it down one more time. So if we break down between 0 and pi over 2, that would be pi over 4. And just think of breaking down something into fourths. That is 1/4, 2/4, 3/4, 4/4. Okay. So now let's remember what happens for the y's. Now we only have 2 y's to calculate here. We already have vertical asymptotes in 3 spots. So this is going to be -3 times the old y. So here's where the old y goes, wherever the cosecant is sitting. That's where the old guy is. So that's -3 times our old y. So our old y was 1. This is just going to be 1 times -3, -3. And this one's going to be -1 times -3, or +3. Didn't I predict that the first one is going to go down now, where the second one is going to go up? As far as a vertical shift or a midline, there is nothing added in right here. So there is none, or you can say 0. The midline is at 0. So the middle of our upper bump, lower bump, upper bump, or in this case, our upper parabola, lower parabola, upper parabola, lower parabola is going to be at 0. Now we need to get our graph paper ready. So let me mark the halfway points, please. I'm going to put the little halfway marks here. I'm going to count by pi over 4s. That's our largest denominator. So I need every 4 units to make a pi. So if you count 1, 2, 3, 4, there's a pi. And then I'm going to go in the opposite direction. And that's going to give me a -pi. My heights are 3 and -3. So I think we should be okay going 1, 2, 3, and 1, 2, -3. So when I graph these, the first thing I like to put on is my midline, and then the vertical asymptotes, okay? So we have a vertical asymptote at 0. Put it on there. We have a vertical asymptote at half of a pi, which is between 0 and pi. And then we have a vertical asymptote at pi. Now, these vertical asymptotes repeat endlessly for our graph paper. So equally space them, put them all on as many as can fit on your graph paper. Fill up your graph paper, fill up your graph paper, fill up your graph paper. Because these continue endlessly forever and ever. If you were to put this into Desmos, you could keep scrolling outward and outward and outward, and they would just keep being more and more and more of them because they go on forever and ever from left to right. Now we are ready to put our upper and lower little dots so then we know where our pseudo parabola sort of things are. Okay, so let's put our -3 on. At 1/4, we are down at -3. That's a lower bump. It's below the midline, so it's going down. At 3/4, we are at +3. That one is going up. And now that we know the pattern, this one has to be down. This one has to be up. This one has to be down. This one has to be up. Now, if you counted on your graph paper differently, that's okay. As long as if I look at a certain dot, like let's say this point here, on your graph paper, I better know that that's 3/4 and a height of 3. So please make sure you're labeling your graph paper however you decided to label it. The asymptote should hit the same spots that mine did. You know, it might have been squished a little differently otherwise. But that is our first cosecant graph. I'm just going to let that sit there till everybody is caught up with their graphs. Yes. Are there any questions about the graph that we ended up getting? Okay, let everybody catch up, and then we are going to do another one. Everybody good? I think we still have a little bit of few people working, and then we'll scooch on to the next one. Okay, so that is our first cosecant graph. So then let's do one more. Okay, so the first thing I am going to do, just as I have done in the last one, is I am going to make, for my reference, a little table for the sine and the cosecant. So it goes 0 and 0. Pi over 2 is at 1. Pi is at 0. 3 pi over 2 is at -1. And 2 pi is back at 0. So our cosecant is the reciprocal of the sine. So this is a vertical asymptote 1, vertical asymptote -1, vertical asymptote. And then let's make up a chart eventually for our new graph. So always write what's happening. Now, if you memorize this and this, you don't need to write that. But if you memorize the sine and the cosine, you'll know the secant and the cosecant kind of for free. Okay, now that we've kind of done that, let's go ahead and talk about the 4 things. We'll put on here midline as well. The stretch is just the amplitude number, this number right here. So that 2 tells us the spacing between the midline and an upper parabola and a lower parabola. Next, the period. We're going to set x over 2 equal to 2 pi. Now that 2 is in our denominator. So how could we get rid of that division by 2? Multiply by 2. So if we multiply both sides by 2, you'll see that this one has a period of 4 pi. It's really stretched itself outward compared to the other one. The phase shift tells us the start of our graph. It's where our parenthesis, we don't really have a parenthesis. You could think of it as having a parenthesis right there. It's where x over 2 equals 0. And our ending is always where the parenthesis or the inside stuff equals 2 pi. Now, we've already done this one. We got 4 pi. So because we didn't have a plus or minus, the phase shift and the ending are the same. That doesn't always happen, so don't think that it will. Here, if we multiply both sides by 2, 0 times 2 is just 0. So we start at 0, we end at 4 pi. Now that's a really great one to break apart. You're going to see that we're going to end up just breaking it down by pi's, because this would be 2 pi, this would be 1 pi, this would be 3 pi's. So 0 to 4 pi counting by fourths is great, because it's just going to be 1 pi, 2 pi, 3 pi, 4 pi. Remember, our phase shift is that starting where x over 2 equals 0, so it was 0. That's our starting place. We do have a vertical shift this time. That's this number right here. That tells me we're going to go down 1. So our midline is at -1. So we have our x's, but we don't have our y's. So remember, our y's are going to be 2 times the old minus 1. 2 times the old minus 1. So the only ones we have to check, remember, for a cosecant, our vertical asymptotes are the first, the third, and the fifth. So the only math we have to do is for the second spot and the fourth spot. Well, this would be 2 times 1, or 2, minus 1, which is 1. This would be 2 times -1, which is -2, minus 1, or -3. Let's scooch this over just a little bit. Okay, so now we're ready to get our graph paper together. We're going to count by pi's. Okay, so we're going to have, that's going to be 1 pi, and 2 pi's, and 3 pi's, and 4 pi's, and I think you get the drift. Now, our highest value is 1, our lowest value is -3. So I think if we kind of did what we did before, 1, 2, 3, 1, 2, 3. First thing I like to do when I'm graphing is I put on my midline, and I like to put on my asymptotes. Asymptotes are really helpful to put on any type of graph, whether it was earlier in the year when we did some rational functions, or if we do these functions. You got to put on those asymptotes. So let's put our middle line on. That middle line was at -1. So let's put that one on just as a guide. Then let's put on our vertical asymptotes. We have one at 0, at 2 pi, and at 4 pi. Now that we know the spacing, everything on these are equally spaced. We can put on any extra ones that fill up our graph paper. I am the best asymptote maker. Okay, so there we've got our asymptotes. So now we just need to make our upper bump and our lower bump. So we find out where those values are at. Now let's look at this one. At pi, we are at a height of 1. That's bigger than -3, so that's an upper bump, or an upper little parabola thing. So at pi, we are at 1. That one is the highest one. It's above the midline, so that one goes up. At 3 pi, we are at -3. That one is below the midline, it goes down. Now here's how you can check you're right. These should be equally spaced. This should be 2 up, 2 down. Those should be equally spaced. And now we should count and put on the rest of our bumps. So now that we have where our upper and lower goes, this one would be an upper, put it on, make it go up. This one would be a lower, put it on, make it go down. Upper, up, lower, down. So that is our cosecant graph. If we were to graph the sine associated with it, the sine is right here. So the sine kind of bounces off of that sine function. And that is how we graph our cosecant functions. Now, if you looked at the homework below, which we'll look at here in a moment, they're kind of combined. 1 and 3 were secants. That's what you'll turn in for the 8-2C homework. Problem 3 and 4, no, I'm sorry, problem 2 and 4 are the cosecants. That's what you turn in for the D homework, okay? So that is how we graph a cosecant. So again, if you look here, 1 and 3 are secants. That's what you turn in for the 8-2C homework. 2 and 4 are cosecants. That's what you're going to turn in for the 8-2D homework. So for the remainder of class, if you want to start working on those, that would be great.